Hello, we the students of Ishwari Engineering College Chennai are presenting a project on Gleis Mishap prevention system. Gleis means rail, mishap means mishappenings. Yes, as you all guess, our title sounds Train Accidents Prevention System.
In accordance to the major accidents that occur as a result of minor cracks in the rail passage, this project has been originated with a motto to prevent several accidents and in saving invaluable lives. As of now, with the present scenario that comprises of train system as a main source of transportation in India and with the emerging metro rail system, this project takes its place to be important, aiming at the prevention of the toppling of the train that approaches a crack. We have established three modules. Firstly, the sensing device precisely to that of a carriage of a train, then the train which approaches the crack, and finally the nearby service station. For the prototype, we have used GPS service to transfer and also receive signals. The sensing unit, which is exactly followed by the train, is speed synchronized with the approaching train, so that even when the sensing unit topples, the train ceases. As soon as the sensing unit stops, it sends signal to the nearby service station, which not only remains a signal but also indexes a command to various other trains that approaches the crack trespassing the same track. Communication system. The module used for communication is the SIM, Subscriber Identity Module Communication. The signals received through the sensors trigger the SIM module to send an electronic text data or SMS to a similar module SIM in the service station, which transmits the data to the SIM module positioned in the approaching train. The communication process follows the flowchart depicted as below. Sensors. Proximity sensors. To interpret the speed of the sensing unit and send the signal to the approaching train, thereby controlling the speed of the train, we use proximity sensors. This provides the speed synchronization between the sensor and the approaching train. IR sensors. To detect the cracks in the innumerable ranges and send similar data to the service station, we use IR sensors. Ultrasonic sensors. To sense any kind of obstacles in the path of the train and perform signal transmission to prevent collision with the obstacles, we use ultrasonic sensors. The sensor used for the detection of the object uses the ultrasonic transceiver IC of the Texas Instruments. Real-time problems. The rails where a Metro North Railroad train derailed on May 17 in Connecticut had been repaired a month before the accident that snared commuters and injured at least 75 people. Maintenance records showed that a cracked rail was discovered in April at the stop where one train jumped the track and was struck by a second train on an adjacent rail in the city of Bridgeport. The Hatfield rail crash was a railway accident on 17 October 2000 at Hatfield, Hertfordshire, UK. Although the accident killed fewer than the other accidents, it exposed the major stewardship shortcomings of the privatized National Railway Infrastructure Company Railtrack and the failings of the regulatory oversight which the company displayed in its initial years. Fractured tracks caused rail accidents on October 3, 2004 in the city of New Delhi. Of the 100 accidents, at least 7 take place due to fractured tracks is the statement of railways. The hairline cracks are not visible to the naked eye. These have to be seen with the help of lenses and ascertained by an ultrasound rail flaw detection method. The further developments. For communication purposes, the simple GSM Global system for mobile communication services can be replaced with that of the global positioning system so that the communication is globalized. For flawless power supply, the sensing unit can be charged with the power supply along the lateral sides of the railway track using a step-down transformer.
Here is our Gleis Mishap prevention system encompassing three vital parts: sensing unit, locomotive with the receiving unit, and the service station which picks up the detected crack messages. Here, a mobile phone plays the role of the receiving station. Sensing unit. The foremost unit embraces the power supply and three sensors. Ultrasonic article sensor, which senses four front objects, which uses Texas Instrument Transceiver IC. Proximity sensor for speed synchronization, and IR sensor that perceives the cleft. Running locomotive, which has the receiving unit and supply. This has a Texas Instrument ADC which transfigure the spotted analog signals to digital signals, which are shown in the display system. The aftermost part is the receiving station, which receives the depicted slit signals. The sensing unit is switched on. The sensing unit started. The train started. The sensing unit detected the crack and it stopped. Message has been sent to the train and the receiving station and the train stopped. Our Gleis system has one plus fantastic feature. The four front objects are detected by an ultrasonic sensor and the messages are sent as stated before. The sensing unit started. The train started. An object comes in front of the sensing unit and it stopped. Message has been sent to the train and it stopped. The receiving station also received the object detected message.